If you're worried about managing your service, then stop worrying. All you need is Lambda. Lambda is one of the services that falls on in the compute domain of services that AWS provides. Hi everyone, and I welcome you all to this video on AWS Lambda tutorial. Today, we will learn some of the use cases and other global aspects that are forecast. Before we begin, please do like, share, and do not forget to hit the bell icon to stay updated on the latest TechCon YouTube channel. Also, check out Adoraka's AWS Master Certificate program, the link to which is given in the description box below. Today we'll be learning what is AWS Lambda, features of AWS Lambda, how is AWS Lambda used, and a hands-on session on how to create a Lambda function. What is AWS Lambda? Lambda permits you to run the code without owning or managing servers. Users only pay for the compute time consumed. You can operate codes for any applications or back-end utility widget administrations. Users upload the code and Lambda does the rest, which provides precise software scaling and extensive availability. Lambda even scales our applications automatically based on the workload size. It scales the application running the code in the response to each trigger. Now let us see some of the features of Lambda. First, serverless architecture. It provides no server management and automatic scaling. In no server management, you do not need to manage your underlying infrastructures, where AWS handles the administration of computers' resources vessor. Lambda automatically scales your application by running code in response to each trigger, scaling precisely with the size of workflow. Event-driven execution. It triggers and customs event source triggers. Here, the Lambda functions can be triggered to have various Lambda services such as S3, DynamoDB, Kinesis, Sense, CloudWatch, API, Gateway, and more. In custom event sources, you can create custom event sources to trigger Lambda function from your applications. Next, function as a service. It considers microservice architecture and single function deployments. In microservice architecture, it allows for the creation of highly decoupled, independently deployed units of logic. In single function deployments, deploys individual functions rather than entire applications, making it easier to update and maintain. Next, flexible resource allocation. It has two things: configurable memory and execution timeout. You can allocate memory to a Lambda function from 128 EM2 to 10 GB in 1 MB increment, which in turn affects the available CPU power. In execution timeout, functions can run for a configurable period from 1 second to 15. Next, integrated security. It has two types: IAM permissions and VPC integration. In IAM permission, it uses AWS IAM to manage permissions and control access to AWS services. In VPC integration, the Lambda function can be configured to access resources inside your VPC. Next, development and testing. It consists of multiple language support, local testing, and AWS toolkit. In multiple language support, it supports various programming languages, including Node, JS, Python, Java, Go, Ruby, and Netcore. In local testing, AWS, SAM, and SAM-CLI provides local environment for testing Lambda functions before deployment. AWS toolkit. Integration with AWS Cloud9 ID and AWS Lambda console for development and debugging. Cost efficiency. There are two things: pay-as-you-go and fine-grained billing. Pay-as-you-go. Its charges are based on the number of requests and the duration of a code execution with free tire availability. Fine-grained billing. Here it is: billed an increment of 1 milliseconds of execution time. High availability and fault tolerance. It consists of built-in fault tolerance and automatic failover. In built-in fault tolerance, Lambda function runs your functions in high availability compute infrastructure across multiple agents, which is availability zones. Automatic failovers. In case of failure, Lambda automatically retires and scales. Monitoring and logging. It consists of CloudWatch integration and AWS X-rays. In CloudWatch integration, automatically logs all requests handled by Lambda to Amazon CloudWatch logs, providing visibility into function execution. In AWS X-rays, it provides deeper insights in performance of your Lambda applications by tracing and analyzing user requests. Concurrency and scaling. It consists of provisioned concurrency and concurrency limit. Provisioned concurrency. It ensures that your functions can handle burst of traffic by keeping specified number of function instances initialized and ready to respond. Concurrency limits. It allows you to specify the maximum number of concurrent instances to prevent overload. Integration with other AWS services. It consists of data storage, orchestrations, API gateways. Data storage integrates with services like Amazon S3, DynamoDB, ARDS, etc. for data storage. Orchestration works with AWS step function to build complex workflow. API gateways combines with Amazon API gateways to create RESTful APIs. The last one, versioning and aliases. It has functioning, versioning, and aliases. In functioning, versioning, it allows you to manage multiple versions of your Lambda functions, whereas in aliases, it enables you to create pointers to specify functions versions, simplifying deployments and rollbacks. Now let us see how Lambda is used in different sections. First is, we can see a file processing. In file processing, the image is taken and uploaded into an Amazon S3 bucket, where after a Lambda is triggered. After then, a Lambda reseizes the image and makes it available to your mobile web and tablet sizes. Stream processing. In this, it uses Amazon Kinesis for the social media streams, which is loaded into the Kinesis in real time. Basically, it takes the most trended hashtag news and uses the real-time information where the Lambda is triggered, and the Lambda runs code that generates hashtag trending data, where then it is stored in the Amazon Dynamo database, where the hashtag trends database is stored and it can be used for later social media trends database, when a user is needed figuras. Next one is mobile backend. Whenever a user gets a notification, this is how it works. They'll use the application known as Amazon API Gateway, where it triggers the Lambda, where the Lambda runs the code to look up the friend list and initiate status, update notifications, etc. Finally, after notifying the Lambda, then it stores to the Amazon ends, where status get updated, notification is pushed to your user's friend. Then finally, you'll get the notification where you can see your friend status, which you can see in your mobile phones. Now let us see how we can create a Lambda function and get to know more about Lambda. Before that, if you want to know what is AWS and how to create an AWS account, please check out the link which is given in the description box below. Now you can see that we have opened a console homepage of AWS. Here, before creating a Lambda function, what you have to do is you have to create a S3 bucket. I have already created an S3 bucket here, which is named as Destination 216. What I'll be doing is I'll be using this bucket to upload an image where it triggers the Lambda function so it can resize the image according to your devices. Let me open the Lambda services. Click on Lambda. As you can see that in the right side of the page, there is an option called as Create Function. Before we can create a function, let's see how the Lambda works. There's a sample program here to run a Lambda program. There are different programming languages such as Net, Java, Node, JS, Python, Ruby, etc. As you can see, it gives the output as hello from Lambda, which is successful output. If you want to know more about Lambda, click on Next Lambda Respond to Event. You can see that there is an image where Lambda is triggered every time the invocation is sent. When we send an invocation as image in S3 bucket, the Lambda get triggered and the image is resized so that you can view in your available devices. When we use the number of invocations that we put it in the S3 bucket, it will cost you some money. It depends on the number of invocations that you're providing to the Lambda. As you can see that if I provide a number of invocations, the cost is increasing here. It depends upon the number of invocations that you use. Let me click on Create Function. As you can see that there are 4 types of plans that you can create a function. First is Author from Scratch. Here we'll be creating a function from the scratch. Use has a blueprint. What it does it? It builds a Lambda function from a sample code that is already present in this, which can configure presets from common use cases. So container image. What it does is it selects a container image to deploy your function.